Hey guys, Mrs. Bogan right here. I'm here to help you through your speed notes and the jobs that you guys have for today. But first, you should have already done your warm up. Let's go ahead and go over that now. Your first question was, what is the definition of speed? If you did your homework last night, this should have been pretty easy, but if you did not, you could have looked at the textbook on page 16. Well, here's the answer. The definition of speed is that speed is a measure of how fast something moves or the distance that it moves in a given amount of time. Obviously, if something moves or covers more distance in a short amount of time, then it has a faster speed. So this is kind of stuff that you guys already know. We're just putting science words to things that you already experience in the world around you. I wanted you to look at this picture below. I have two people on a bike. I have a girl in this picture right here and a boy on this bike down below right here. Question number 2 was, how far did each biker go in 2 seconds? Well, if you look at this line right here, this line shows you what distance or how far each biker went. And these little gray boxes tell you their time. So in 2 seconds, the girl right here in this picture covered a distance of 8 meters. In 2 seconds, the boy covered a distance of 4 meters. So question number 3, who had the faster speed, the boy or the girl, and how can you tell? Well, obviously, if you analyze this picture correctly, this girl covered greater distance, so she had a faster speed because in 2 seconds, let's say they both started at the same place, which they did, but in 2 seconds, the girl had gone 8 meters, and in 2 seconds, the boy had only gone 4 meters. So the girl on the bicycle had a faster speed because she covered more distance in the same amount of time than the boy did. Would you please turn to your speed notes on the page that you are completing today? Today you're going to be completing some notes, but for right now, you're just going to listen to this next part. So obviously we know that objects have different speeds. This is a race car, and obviously it has a faster speed than a bicycle. And if we're talking about speed of an object, the speed of an object is determined by how far it can go in a given amount of time. So let's say we gave both of these objects 10 seconds. The race car would travel more distance than a bicycle would, making this race car have a faster speed because it covers more distance but in the same amount of time. The speed of an object is determined by how far it can go in a given amount of time. So here's where your notes are going to start. On slide 1 of your notes, you're going to take these notes and listen to what I say. So we already covered this idea that the speed of an object is determined by how far it can go in a given amount of time. Sorry for that typo, I should say of time right here. So you need to know that speed includes an object's distance and an object's time that it covered. So for example, when I say distance, I'm talking about how far an object can go, and when I say the time that it took, you might hear these words like how long or how much time did it take the object to go. Something else you need to know about distance is that units for distance might include things like kilometers, meters, centimeters, miles, which is not metric system, or inches, which is not metric, but those are units of distance. When we're talking about time, we might use units like minutes, seconds, hours, even years, milliseconds. Anything related to time like that can be a unit to measure time. You need to know that 2 things are included when describing an object's speed: an object's distance and an object's time, which you guys already know. Like if we're talking about the speed of a car, we would say that a car would travel 65 miles, that's the distance, per hour. How many miles can it cover in a given amount of time? That's the miles per hour. That's where a car's speed comes from. Take a moment to answer the question for slide number 1, and then we'll move on to slide number 2. Here's your notes for slide number 2. When we're looking at a problem that has units of time and distance, we're going to make certain marks, and here's what I want you to take notes on. Whenever you see a number that has a time, we're going to circle it, and we're just going to remember that because clocks are round, so we circle a number that is a time. So for example, here's a problem. Robin drove her car to Fresno. Without kids in the car, it took only 3 hours. Hours is a time, so in this type of problem, we're going to circle it because, like I said, clocks are round and time is measured with clocks. That's just a funny way to remember. She drove 300 miles, and then I'm going to stop. When we measure miles, we can remember the mark that we're going to make because we measure miles or distances with a ruler, and rulers are straight. So we're going to underline a number that is a distance. So 300 miles is a distance. Rulers are straight, so we're going to underline it. But when she had the kids, she had to stop a lot, so it took 4 hours. That's a time. Clocks are round, so we're going to circle it. Would you take some notes on what kind of marks you would make if you see a number that is a time versus a number that is a distance? Here's something else you need to know. Based on this information, we can figure out that Robin traveled a speed of 65 miles per hour. Now here's the thing. If I have a speed has distance and time, so I'm going to circle it as well as underline it. Take a moment to answer the question, draw a picture or some examples, and answer the question for slide number 2. And now we're going to go on to some problems. If you follow the instructions, when you read these problems, you're going to underline the distance, circle the times, and you're going to circle and underline any number that gives you a speed. So for example, number 1, Lance Armstrong rode his bike in Spain for 24 hours without stopping. 24 hours is a time. Clocks are round, so we circle it. In that time, he went 400 miles and won that race. This number right here, 400 miles, is a distance. Rulers are straight, so we underline the distance. Number 2, the race car driver drove at a speed of 120 miles per hour. This right here is a speed. I know because I have a distance and a time, miles and hour, so I'm going to circle it and underline it because speeds has both time and distance. The race car driver drove at a speed of 120 miles per hour. Is he driving around the half-mile track? Sorry about that. He is driving around the half-mile track. Half mile is a distance, so we underline. I'm going to do one more for you, and then you are on your own. A snail decided to go from the flower bed to the window. He was so slow that it took him 2 days to travel 3 meters. 2 days is a time, because that's how long it took him to travel, and 3 meters is a distance. So you are on your own for the rest of these problems, and then continue to follow the directions so that you can complete and watch another video and complete the rest of your page for today. I hope you guys have a good time learning today and hope you have a nice weekend. Thanks.